Bismillahirrahmanirrahim. My dear students of class 10 business studies, I hope that you all are getting well and you are getting preparation for the upcoming exams. I, Roxana Parveen, Senior Lecturer, Department of Biology, Milestone College, welcome you all to the online class from Chapter 10, Science. And today we'll get to know different aspects of force and inertia. After having this class, we'll be able to know the basic concepts of the force and inertia, practical examples of force and inertia, Newton's 3 laws of motion, explanation on Newton's laws with examples, mathematical explanation on Newton's second law, and finally, mathematical measurements on Newton's second law. So let's get started. We all know that what is force and what is inertia from our previous classes. What is force? In physics, force is defined as the push or pull on an object with mass that causes it to change its velocity. Force is an external agent capable of changing the state of rest or motion of a particular body. It has a magnitude and a direction. You see in the diagram that two people are pushing a large object by force, okay, and the object cannot move because the both of the sides of this object is getting force equally. So there is an explanation of inertia. From our day-to-day experiences, we see that every object tries to maintain its present state. You see in the diagram very carefully, if an object is at rest, it tends to be at rest, and if it's in motion, it tends to be in motion. Until force is applied, the tendency of an object to remain in its present state is called inertia. The tendency of an object at rest to maintain rest is called inertia of rest, and the tendency of an object to motion to continue its uniform motion is called inertia of motion. So you got to know that inertia is of two types. One is the inertia of rest, another is inertia of motion. You see, a people is driving, some people drive when any heartbreak is actually occurred, then a person moves forward. When they starts to move, then the people or the driver can move backward. You see the two person over there sitting. One is sitting in this bus or metro rail, another is standing up. You see the man is holding the hook and is keeping his body in own balance according to the movement of this train or the tram, right? And here is the diagram. You can have the practical experience that how it occurs. You see, when you put a coin over a straight paper and place it on a glass, when you just tip it a bit faster, the coin gets down in the water. You see, the tendency of the coin was to just stay at rest. That's why it just fall down in the water. Okay, the opposite things occur over there. At the left side, you see some small ping pong balls or some objects are here. The tendency of the to preserve its state of motion, and the next diagram is just it is having a kind of movement in presence of the gravity. What is inertia and mass, and what's their relationship? A body at rest continues to be at rest, and the body in motion continues to be in motion. It is called inertia, you already know. Okay, the inertia of a body is measured by the magnitude of force required to change the state of the body. So the force required to change the state of a heavier body is more than the force required to change the state of the lighter body. That means you have to apply force larger for the large objects or heavy objects than smaller than the lighter object. This is because the mass of the heavier body is more than the mass of the lighter body. So the mass of a body is a measure of its inertia. The same diagram, just as I've shown before, that a person is standing when just the bus gets, or the truck, or any kind of vehicle gets a hard brake, it just gets lean or gets forward. Okay, but the lower part of the body tries to keep its own balance with the state of rest. Okay, so how can we know the amount of force in Newton's second law of motion? Actually, the Newton's second law of motion is related to the mass and acceleration. So from first law of the Newton, we came to know that the change of the state of an object, such as to change an object at rest into an object in motion or vice versa, the force is to be applied due to inertia of the object. The more the inertia of an object, the more force is to be applied on that object to change its state, right? It's normal. Have you even you ever tried to just push your wall to any other direction? It's not possible. You might try, because the wall is more will push more pressure on you instead. The more the inertia of an object, the more is to be applied on the force is to be applied on the object to change its state. The amount of inertia is actually the force. Therefore, the more the mass of an object is, the more force is to be applied on that object to change its velocity. Newton's second law of motion explains how much force is to be applied on an object of a certain mass and how much change there will be in consequence. However, before knowing Newton's second law of motion, we have to know about two terms. One is momentum and the other is acceleration. What is momentum? Momentum, product of the mass of a particle and its velocity. Let's make it quite simple. Momentum is a vector quantity. You might have the objective, but what kind of vector is this? This is the vector quantity. It has both magnitude and direction. Isaac Newton's second law of motion states that the time rate of change of momentum is equal to the force acting on the particle. It's written in the bold, just observe it very carefully. The unit of momentum is the product of the units of mass and velocity. In in SI units, if the mass is in kilograms and the velocity is in meters per second, then the momentum is in kilogram meters per second. Being a vector, momentum has both magnitude and direction. The momentum calculator uses the formula such as P equals mv, m for momentum, v for velocity, or momentum is equal to mass times velocity. Okay, you see the formula? Right, let's do some maths on it. The momentum, that means the P of an object, is defined as the product of its own mass m and velocity v, that is P equals mv, we all know. Momentum has the both direction and magnitude. Its direction is the same as that of velocity v. The SI unit of momentum is, we all know that, kilogram meter per second. Kilogram meter per second. Since the application of an unbalanced force brings a kind of change in the velocity of the object, it is therefore clear that a force also produces a change of momentum. The mathematical formulation of the second law of motion is, suppose an object of mass m is moving along a straight line with an initial velocity u. That means the velocity of an object initially remains as u. It is informally accelerated to velocity v. That means the second time an object gets the velocity v. That means u is the previous velocity and v is the latter velocity. Okay, t by the application of a constant force F throughout the time t. The initial and final momentum of the object will be P1 equals mu and P2 equals mv respectively. I guess you can understand the change in momentum equal to P2 minus P1 or mv minus mu. If we make the m in common, we can get v minus u. It means v is the latter velocity, u is the previous velocity. We have to subtract. The rate of change of momentum is equivalent to m into v minus u into t. The unit of force is kilogram meter per second square, or kilogram meter per second, or Newton. That means we have to put the unit of force is Newton. Simply we can symbolize as capital N. The second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration. The second law of motion is often seen in action in our everyday life. Have you ever noticed that while catching a fast-moving cricket ball, a fielder in the ground gradually pulls his hands backwards with the moving ball? In doing so, the fielder increases the time during which the high velocity of the moving ball decreases to zero. Thus, the acceleration of the ball is decreased, and therefore the impact of catching the fast-moving ball is also reduced. If the ball is stopped suddenly, then its high velocity decreases to zero in a very short interval of time. Thus, the rate of change of momentum of the ball will be large. Therefore, a large force would have to be applied on holding the catch that may hurt the palm of the fielder. In a high jump athletic event, the athletes are made to fall either on a cushioned bed or on a sand bed. This is to increase the time of the athlete to fall to stop after making the jump. This decreases the rate of change of momentum and hence the force. Try to ponder how a karate player breaks a slab of ice with a single blow. Okay, fun apart. What's the formula? F equals ma. F for force, M for mass, A for acceleration. Okay? Let's see what's happening next. What is acceleration? Acceleration is the change of velocity over the time. Then that means if the velocity of an object changes from u to v over a period of time t, then acceleration is equals v minus u by t. That means with the time, the speed or the velocity increases. I repeat, with the time, the velocity increases. If we have understood momentum and acceleration, then it is very easy to understand Newton's second law. The Newton's second law is that the rate of change of momentum of a body is proportional to the force applied. But force is defined in such a way that we can say equal instead of proportional. That means if the momentum of an object changes from mu to mv, then the change of rate is ma. That means m within bracket v minus u by time. Okay, the applied force will be equal to F. It means this formula. The unit of force is simply Newton. 1 Newton or capital N is the force required to accelerate an object with a mass of 1 kilogram at the rate of 1 meter per second square. What's the homework? Okay, so you have to learn whatever was in this lecture, and you have to take the help from books, and you may take help from the online resources though, but you have to understand that this chapter is very easy, and you can get all the creatives in every year in the board exams. Okay, so let's learn some home tasks. Solve the CQ number 1 from your textbook exercise and define force, inertia and acceleration, and get a very good preparation on this chapter. Till then, thank you.